Hi, we're Group 13, and our project is to design a solar heated swimming pool. Our problem is that a motel manager is looking to save money by implementing a solar heating system for their outdoor pool as opposed to a traditional gas heater. They've asked us to design a system to allow for a comfortable water temperature year-round, and we can only use solar energy to heat the pool. The system is to feature flat panel solar collectors that will be fixed to a structure above the pool. The requirements for this project are that the water in the pool must maintain a comfortable temperature. We need to select the number of solar collectors along with the placement, orientation, and location. The system must be able to be operated year-round. We need to select the pump, piping, and materials of construction, and the total cost of the system, including operating costs, must be determined and compared to that of a gas heater. So for our location and climate, we're assuming that the pool is in a location that's available for year-round swimming. In this case, we're going to assume the pool is in Miami, Florida. The lowest monthly average temperature there is in January, which falls around 63 degrees Fahrenheit. A comfortable temperature range was chosen to be 78 to 82 degrees Fahrenheit. The system would only heat to a temperature of 82 degrees Fahrenheit and turn off when temperatures exceed that.
Moving on to preliminary design. Heating was achieved through solar collectors, which convert solar energy into heat energy. The main assembly of the system includes one intake with a strainer, pump, filter, and solar collectors erected on a structure and connected in series. The water is pumped through the solar collectors and recirculated into the pool. A strainer, filter, and associated pipe/fittings were not included in the total cost of the heating system, as they are required to be there regardless of heating system implementation, and because they were not required in the project design. And lastly, a check valve and a flow control valve allowed for heating control by adjusting the flow through the collectors based on temperature input from both the air and the water. This prevents the system from continuing to heat when unnecessary.
For our final design, the solar collector piping was changed to a parallel configuration. This allows the system to handle the maximum specified flow rate at 77 gallons per minute. 2 inlets were added into the pool in accordance with the Association of Pool and Spa Professional standards. Solar collectors are angled at 24.5 degrees facing south to achieve optimal solar absorption based on Miami's location. Row to row spacing was set at 5.5 feet to prevent shadow interference from other solar collectors. The pump selected for our system was the Hayward Model Performance HCP55, which provides 5.5 horsepower to accommodate for the required volumetric flow rate of 77 gallons per minute and allows for a total head loss of 69.5 feet. PVC pipe for the outlet of the pump was determined to be 2-inch nominal Schedule 40 pipe to allow for an economic water velocity of 7.5 feet per second. 13 10 by 4 foot solar collectors made by FAFCO were chosen to provide a total heat transfer rate of 81,952 BTUs per hour during suboptimal conditions.
Taking a look at the cost analysis for the system, the installation of the solar heated pool would cost around $17,000. This is largely due to the labor and material costs for the roof. Additionally, the pump requires 3.36 kilowatts to operate, which will amount to about $250 a year. On the other hand, when looking at the gas-powered system, it'll cost significantly less to install, only at around $2,000 to $4,000, but will cost around $2,900 per year to operate. So taking the numbers into account, the solar heated pool should make up for its heftier initial costs in around 6 years.